So in this lesson, we're going to be deriving linear equations from a table. So remember, first off, our linear equations are going to be written in slope-intercept form, which is y equals mx plus b. And remember, a table is basically an input and output table between the variables x and y. X is always going to be your input, y is always going to be your output. Now, if I give you a table, if I don't already tell you it's linear, you need to do one of two things if you need to derive a linear equation from it. One, you need to determine whether or not it is linear, which is different from it being proportional, because all proportional tables are linear, but not all linear tables are proportional. And then after you figure out if it's linear, then you need to figure out the values of m and b. Okay, because remember, when we have y equals mx plus b, we need to figure out the values of m and b. All of the x's and y's in the table are going to represent the x and y in the equation. So if I'm given a table, let's do a simple one. Let's do -3 and there we go. So if I'm doing this, first thing I need to figure out, is it linear? Okay, how do I figure out if it's linear? I need to look at the ratios. Okay, I need to look at the ratios. Is it linear? What are the ratios? Are they all equal? If the ratios are not equal, this is not a linear relationship. So if I'm doing this, how does -5 become -1? You add 4. How does -1 become 1? You add 2. How does 1 become 3? You add 2. Well, how does -3 become 1? You add 2. Here you add 1. And here you add 1. So when I say ratios, I mean the ratios of the change in y, and we're going to write the delta symbol for change in, the change in y over the change in x, or your rise over your run, okay? So my first ratio is 4 over 2, and that equals 2. My second ratio and third ratio are the same. They're 2 over 1, which also equal 2. Since these are the same, okay, this is a linear relationship. Okay, so we already know it's linear. In fact, because we figured out the change in y over the change of x, or the rise over the run, remember this is the same thing as the rise over the run, which is also the same thing as m. We know that m in this case equals 2. We just solved for it. Okay, we just solved for it. Then we need to identify b. Well, we kind of already did that too, because b is your y-intercept, and it's equal to where x equals 0. Well, x equals 0 right here. What is its corresponding y? It's 1. So in this case, b equals 1. So I have my value of b, and I have my value of m. So now I just have to write my equation. Y equals 2x plus 1. And I can check that. If x is negative 3, 2 times negative 3 is negative 6, plus 1 is negative 5. If x is negative 1, 2 times negative 1 is negative 2, plus 1 is negative 1. 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. Okay? This is the equation that represents the table. So what does it look like if a table is not linear? Well, let's see. So if I have this table, okay, again, is it linear? How do I know? I know by looking at the ratios. This also applies to whether or not it's proportional, okay? If these ratios are not the same, it cannot be proportional. We already know that if this were linear, this is not going to be proportional because when x is 0, y should be 0, but it's not, it's 5. And I realized I wrote linear. There we go, linear. So let's look at our ratios. How do I get from 17 to 5? Subtract 12. How do I get from 5 to 22? I add 17. How do I get from 22 to negative 16? I subtract 38. And then how do I get from negative 4 to 0? I add 4. Here I add 6. And here I add 1. Okay? Now, if even one ratio is not right or the same, it's no longer linear. I don't need to go on. So let's look at this. First one, negative 12 and 4. I'm looking for the change in y over the change in x. Okay? This is the same thing as the rise over the run. So negative 12 is my change in y over 4. That gives me negative 3. Let's try the other one. 17 over 6. I can't even reduce that. I can change it to an improper fraction. But 17 over 6 is clearly not equal to negative 3. So because these are not equal to each other, this is not linear. Okay? This is not linear. This table does not represent a linear relationship. I cannot derive a linear equation from here. So I would write not linear as my answer. Let's try another one. Let's say we do this one. start with -9. Let's go to 6, negative. Let's go with that. Okay. So first thing, let's check, is it linear? Let's look at the ratios. If I do this, -5 to -3, I have to add 2. -3 to 3, I have to add 6. And 3 to 9, I have to add 6. -9 to -6, you add 3. -6 to 3, you add 9. 3 to 12, you add 9. Okay? So, change in y over the change in x. How does y change? How does x change? Let's look at the first one. Y changed by 2. X changed by 3. I can't reduce that. I'm going to leave it as 2/3. In the second set, I had 6 and 9. That reduces by 3 to 2/3. Oh, look, they match. And the second one is also 6/9. So that also gives me 2/3. So is it linear? Yes. Do we know what m is? Yeah, because this ratio represents m. That's why we do it this way. M equals 2/3. But now what about b? What about b? How do I find b? So when we want to find b, we need to do one of two things. One is, well, the 0 would be somewhere in here. Figure out what this other value is. The other way to do this is to choose 2 points, or choose a point. 1 point from the table and substitute into y equals mx plus b for y and x, okay? Because we already know m. Well, if we know m and we know a x and a y, then we can solve for b. So how that looks is the following. We know that y equals, we found that m is 2/3 plus, we don't know what b is. Okay, this is all we have. I'm going to pick a point. I'm going to pick 12 and 9. Okay, that means x equals 12 and y equals 9. So I'm going to substitute y equals, sorry, not y. We know what y is. We just said y equals 9. 9 equals 2/3 times 12 plus b. Well, 2/3 times 12, 12 divided by 3 is 4, times 2 is 8. So 9 equals 8 plus b. And if I subtract 8 from both sides, I get b equals 1. 8 plus 1 equals 9. So b is 1. So I just solve for b. And it doesn't matter which of these points I use. I could have used 3, 3. I could have used -6, -3. I could have used -9, -5. Because the equation should work for all of these points. Okay? So my equation is y equals 2/3 x plus 1. That's it. Y equals 2/3 x plus 1. All right. I'm going to have you work on the next one by yourselves. Okay? So I want you to really figure this one out. This one's going to be a little tough, but I think everyone should be able to do it. So don't worry. This sometimes takes a little bit of practice. Just give it a second, okay? So let's do this one. Let's do these 3 points. Okay? Is it linear? Is it linear? What are the ratios? It's the first thing you need to do, so work on that right now. Pause the video and work on that, please. Okay, so this is what you should have gotten. From 3 to -12, subtract 15. From -12 to 17, subtract 5. From -6 to 12, add 18. And from 12 to 18, add 6. Now let's check our ratios. Remember the change in y over the change in x, which is the rise over the run, and this all gives me m. So the first one is -15 is my change in y, and when that happens, the change in x is 18. This reduces by 3. -15 divided by 3 is -5. 18 divided by 3 is 6. And the second one is -5 over 6. Well, guess what? -5 over 6. These are the same. This checks. Okay? So m equals -5 over 6. But what in the world is b? Figure that out. Pause the video and figure out what b is. All right, so hopefully you got b. Remember, if you do not know what y is when x is 0 according to your table, you can figure it out. You can use the slope or m, or again, to find b, pick a point from the table. And substitute the x and y into y equals mx plus b. That didn't work out as I wanted it to. Into y equals mx plus b. Okay, so we're going to pick a point. I'm going to pick the smaller numbers. Let's use this one. Again, it doesn't matter which one you pick. It's going to work out regardless. So far I know y equals, oops, that was the last one, negative 5/6 x plus b. According to this coordinate I just chose over here, I'm going to substitute x as negative 6 and y as 3. So if I do that, I get y equals negative 5/6 times negative 6 plus b. And I forgot that y is 3. Okay, remember y is 3, just like we said here. So I substituted y as 3, and I substituted x as negative 6, and now I'm going to solve this. The 3 stays the same. Negative 5/6 times negative 6 gives me 30 over 6, which is just 5, plus b. And now I'm going to subtract 5 from both sides to get b by itself. And when I do that, these cancel out. This gives me negative 2, which equals b. So now I know what b is. Not only does m equal negative 5/6, but b equals negative 2. So my equation now becomes y equals negative 5/6 x minus 2. I could have also said plus negative 2. But you could also write it as minus 2. It does not matter which one you choose. So that's it for deriving linear equations from tables. Let me know if you have any questions.